As we go on to page 80 now, and winding up this unit, once again, the scan simple here is a good little short reference. Danielle does a nice job on this one as well. Let's take a look now at sales of footballs and soccer balls in billions of dollars are approximated by the function that we see here. And keep in mind we have the natural log of x over here. We don't want to get that mixed up with the 0.11. That's why I changed colors. Now they're also saying that x is equal to 1, and that corresponds to 2001. So what would x be then for 2007? Well, x would be 7. And 2009, x would be 9. So then it's just a matter of plugging in for this estimate sales in 2007. We're going to plug the 7 in right there. So when we do that, just putting all of this in the calculator just like this, and we hit enter, we get 21.44 billion of dollars. And you see footballs and soccer balls are quite a money earner for someone there. Now for the second part of this, that is for 2009, we're going to have x equals 9. We put a 9 there. And when we do so, we get our sales would be 22.72 billion. Okay. Now they also ask for a graph of this. And when I put in this general form here, using Mathway, I get a graph that looks like so. In example 2, we're going to use this function, and it's the number of years required to double your money but invested at interest rate A. So A is the interest rate. So here, to start us off, we're going to plug in 7%, which will be 0.07, and then we add the 1 to that. So in a sense, we can just take that away, and this will become 1.07. So we're going to say natural log of 2 in our calculator divided by natural log of 1.07. Now when we do that, we find out that our doubling time, and it's rounding it off to the nearest whole year, is 10 years. Now if we put a 16 there, and just erase that, and this becomes 1.16, our doubling time now is 4 years. Again, rounding it off to the nearest whole year, putting this divided by the natural log of this, and hitting enter. And then for letter C, this will become 1.23 using the formula from above, and this rounds off to about 3 years. And then doing D, this will become 1.47. The doubling time is 2 years, rounding it off to the nearest whole year. And of course you should verify this by putting this information into your calculator to be sure you're getting these answers. So for example 3, we're looking for life expectancy at birth of a cow born in the year Y and is approximated by this function. Again, we're using natural logs times x here. So what is x? Well, x, we're saying x equals 10 corresponds to the year 2010. So what will x be when the year is 2020? Well, it's going to be 20. And 2055, it will be 55. So what we're going to do now is put a 10 there. Get our eraser, take this out of there, and put a 10 there, and just put this into our calculator. 18.9 plus 15.4 natural log 10. Hit enter, and it comes up to about, for this first one, 54 years. Now, when you put it in there for 20, change that 10 to a 20. I can just do it like this. Put that into your calculator, comes out to about 65 years. I never knew cows lived that long. And here, if you put a 55 there, we'll have to erase that. $18.9 plus 15.4 natural log 55. That gives you 80 years. And try it out. Now when I put this last one, I just checked it here. I see this is the answer they give in the book, but I get 80.6. So if I'm rounding that off to the nearest whole year, I would think they would put 81. So again, it has to do with rounding and things. And, you know, if they're going to count 80 correct and 81 wrong, when I get 80.6, I'm going to have to challenge that. And again, if you know how to do it, I would give you credit for that. So our last example here, the average annual expenditure for a consumer of milk and eggs can be approximated by this function. Again, they're including natural log there, not to get that confused as a 1 as you look at it here. Of course, it makes it clear there. Where x equals 1, it corresponds to the year 1991. So 1995 would be 5, and 2005 would be x is 15. So we're going to, they want us to do it for 1995 and 2005. So we're going to substitute our x here after we erase this x as a 5. So again, you're going to put a negative this plus this positive natural log 5 into your calculator, and you end up with, for when you do a 5, 905.70. And then keep in mind that this, we're rounded it to 2 decimal places. Okay, we don't know how much that is. It's probably just plain dollars here. So just under $1,000 per person. Ooh. All right, now I know I don't eat eggs and I don't drink milk, so that couldn't be me, but my wife probably makes up for me. All right, let's put a 15 there. Erase this. Put a 15 there. So again, negative this plus this, hit natural log 15, and then you get 2,000. Wow. Now here, they want us to do a graph of this, and I did one. And this is the shape of the graph that I got. And you see the numbers are quite large, so they wouldn't fit on any small graph, but it gives you the shape that it's exponential growth, and it starts and then it sort of levels off. Okay, well that'll complete this unit. This was only just under 12.